Said it works well to rewrite these things to line up your like terms. So I'm gonna rewrite this just a little bit. I'm gonna take that top equation and just kind of write it the way it is. On the bottom equation, though, I'm gonna shift that x squared over, and then there's no x term in it, so I'm gonna leave that space empty. And then I'm gonna write plus 4y squared here equals 4. Now, to eliminate these, I can't just add these two equations together and have something drop out. But just like with a linear equation, if I multiply this by -2, that's going to give me -2x minus 4y squared equals -4. Now when I combine those, what I get is, let's see if I can move this all up. I'm going to get x squared minus 2x. The y squareds disappear, and the 4 minus 4 also disappears. That's nothing special. That's just for this equation. But dropping out the y's is important. So I see a greatest common factor of x. That tells me when x equals 0, it's a solution, and when x equals 2, that's a solution. And now I got to go find some y's. Know those are solutions, so I had to try each one of them, and I'm going to use the first equation. So when x equals 0, that leaves me 2y squared equals 2. Divide both sides by 2, that gives me 1. Take the square root of that, I get y equals plus or minus 1. So the solutions are going to be 0, -1, 0, +1. And now when x equals 2, 2 plus 2y squared equals 2. If I subtract 2 from both sides, that leaves me 2y squared equals 0. And then when I divide by 2 and take the square root, I'm still going to get 0. So the other point is going to be 2, 0. Now, we should graph these to check. Went out to Desmos, put the first equation in the first line, second equation in the second line, and notice that is where those points intersect. So I did it correctly. And so that's another way of solving using elimination.